the first session on the continental drift theory, we tried to understand the background of the theory on the drifting of the continents. The most comprehensive and complete theory regarding the drifting of the continents is proposed by Alfred Wegener. The earlier session, the basic premises of the theory, concept of Pangea, direction of the drifting of the continents, forces responsible for the drifting of the continents, and contribution of this theory in the process of fold mountains building activity and formation of island arcs is discussed at length. After analyzing the theoretical and conceptual background of the theory on the drifting of the continents, it is now the time to evaluate this theory. The aim of this lesson is to analyze the evidences or proofs in support of this theory, to critically evaluate the theory, to analyze the contribution of this theory. In support of this theory of continental drift, Alfred Wegener gathered geological, climatological and paleontological evidences. Wegener has provided some evidences to prove the unification of all landmasses in the form of single landmass, that is Pangea. Some of the important evidences given in support of the theory are as follows. The concept of jigsaw fit is related to the fitting or matching of the continents. There is a remarkable similarity between the coastlines on the opposite sides of Atlantic Ocean. The outlines of the coast on two sides of the Atlantic Ocean are such that they can be easily matched or fitted, and it appears to be detached portion of the other. The eastern coast of South America, the Brazilian Bulge, can be fitted against the western coast of Africa, that is Gulf of Guinea. According to Wegener, there is a geographical similarity along both the coast of the Atlantic Ocean. Both the opposing coast of Atlantic can be fitted together in the same way as two cut off pieces of wood can be refitted or matching pieces of a torn newspaper. The coastlines of South America and Africa have a remarkable match. Some scholars are of the view that fitting of coastlines may not be correct, since the coastal areas are subject to both erosion and deposition. Over a long geological period, a map produced using computer graphics is prepared to find the best fit of Atlantic coast along South American and African coast by Bullard in 1964. The fitting of the coastlines on either side of the Atlantic was tried at 1000 fathom line instead of present coastline. The map thus prepared based on the computer programming proved to be quite perfect. Geologically, both coasts of the Atlantic Ocean are also identical. A detailed study of the eastern coast of South America and western coast of Africa revealed that geological structures of both the coasts are more or less similar. The continental margins on both sides of the Atlantic Ocean fit together, not only in outline but in rock formation also. The rocks on either side of the Atlantic Ocean are geologically of the similar nature. The belts of ancient rocks of 2000 million years from the Brazilian coast are similar to the geological formation with those from the Western Africa. The mountain system on the either sides of the Atlantic coast also have similarity. The Caledonian and the Hercynian mountain systems of the western and eastern coastal areas of the Atlantic Ocean are also identical and similar. The Appalachian Mountains of northeastern region of North America, which seems to disappear in the waters of Atlantic Ocean, finds its continuity and resurfaces again on the European coast near British Isles and Scandinavia. The occurrence of placer deposits of gold along either sides of the Atlantic coast provides evidence about the drifting of the continents. Placer deposits such as gold is found in Ghana coast in West Africa, but the source, the gold bearing veins, are in Brazil, and it is obvious that gold deposits of Ghana are derived from the Brazilian plateau when the two continents were located side by side. Geological evidences show that Caledonian and the Hercynian mountain systems of the western and the eastern coastal areas of Atlantic Ocean are similar and identical. The Appalachians of the northeastern region of North America are similar with the mountain system of Ireland, Wales and northwestern Europe. Paleoclimatic evidence for continental drift includes deposits of coal, desert sandstone and glacial deposits. These deposits indicates a specific climatic condition at the time of its formation. The distribution of these deposits is best explained if one assumes that continents were once grouped together. According to Wegener, the large mid-latitude coal deposits which stretch from North America to Europe to China date to the Permian Carboniferous periods existed because these regions once were more equatorial in location and therefore covered by dense vegetation that now became coal. The coal formation on eastern North America and Europe are of similar nature. The geological similarities in terms of age of coal deposits and their nature and formation provides evidence of the continental drift. The paleoclimatic records permit us to reconstruct the climatic zones in the past. It has been reported from the geodetic evidences that Greenland is drifting westward at the rate of 20 centimeters per year. The evidences of seafloor spreading after 1960s have confirmed the movement of land masses with respect to each other. Greenland is drifting towards North America. Drifting of Greenland is confirmed during the geodetic survey conducted by American scientists in the year 1823, 1870, 1917 and 1970. One of the biological evidence is provided by Alfred Wegener is related to fossil formation. Fossils are the dead remains of plants and animals which are embedded in the rocks. Fossil remains of both animals and plants supports the concept of drifting of the continents. Identical species of plants and animals adapted to living on the same land or fresh water are found on the continents separated by the oceans, that is Atlantic Ocean. There is a marked similarity in the fossils found in the eastern coast of South America and the western coast of Africa. The observation that lemurs occur in India, Madagascar and Africa led some to consider a contiguous landmass Lemuria linking these three landmasses. The striking similarity of certain fossils found on the continents on both sides of Atlantic Ocean is difficult to explain unless the continents were once connected. Fossils of Glossopteris, a fern-like plant, have been found in the rocks of same age from South America and Africa, peninsular India and Australia. The simultaneous presence of Glossopteris on all the southern continents is the strong supporting evidence that the continents were once connected or united. Mesosaurus was an extinct reptile adapted to shallow brackish water. The remains of these animals in the form of fossils were found in South Africa and Brazil. These two locations are presently 4,800 kilometers apart with an ocean between them. Therefore, their distribution in Africa and South America indicates that these two continents were together in the past. During the latter part of the Paleozoic era, about 300 million years ago, glaciers covered large portions of the continents in southern hemisphere. The deposits left by the ancient glaciers can easily be recognized in the form of tillite, that is glacial deposits. The glacial deposits in the form of tillites in peninsular India, Brazil, South Africa, Madagascar, Australia, all these locations are a part of Gondwana land, had remarkably similar in nature. The glacial tillite provides unambiguous evidence of drifting of the continents. All the continents in the southern hemisphere, such as Australia, Brazil, in South America, South Africa, etc., show the evidence of glacial landscape. It indicates that these continents, which are mostly in the tropical region, were located near the poles. The evidences of the Carboniferous glaciations of Brazil, Falkland, South Africa, peninsular India and Africa further prove the unification of all land masses during the Carboniferous period. The geophysical evidence is related to the drifting of the continents is provided in the concept of polar wandering, that is movement of the poles. According to Wegener, there has been changes in the position of the poles in the different geological periods, which he calls as polar wandering. During the Silurian period, the North Pole was located 14 degrees north latitude and 124 degrees west longitude, and the South Pole was located northwest of Madagascar in the Carboniferous period. The North Pole was at 16 degrees north degrees latitude and 147 degrees west longitude, and the South Pole near Durban in Natal or South Africa. During the Tertiary period, the North Pole was at 51 degrees north latitude and 153 degrees west longitude, and the South Pole shifted near 53 degrees latitude. According to Alfred Wegener, Pangaea was initially splitted into northern and southern block. He called the southern block as Gondwana land. Peninsular India or South India forms a part of the Gondwana land. Gonds is the major tribe of the peninsular India. It seems that the term Gondwana is derived from the word Gond. The presence of Gonds in South India is in support of the Wegener's observation that peninsular India is a part of the ancient landmass, that is Gondwana land, which emerged after the breaking of the Pangaea. The continental drift also attempted to solve the problem of the origin of the folded mountains of Tertiary period. The frontal edges of the westward drifting continental blocks of North and South Americas were crumpled and folded against the resistance of the rocks of the seafloor, that is SEMA, and thus the western cordilleras of North and South Americas like Rockies and Andes mountains chains were formed. Similarly, the alpine range of Eurasia. Alfred Wegener's continental drift theory widely departed from the contemporary geological ideas of the 19th century. Wegener handled his case as an advocate rather than as a scientific observer. The critics of the Wegener's continental drift theory fall under two broad categories. One, the critics and the writers who always attempted to search errors and the discrepancies in the theory. The second, the scientists who attempted to modify and correct the original theory while retaining the basic concept or tenets. Some of the limitations and defects pointed out by various scientists in Wegener's theory of continental drift. One of the major criticisms leveled against the theory of continental drift is related to the forces leading to the drifting of the continent. The force identified by Wegener in the drifting of the continents is gravitational force and the force of buoyancy and the tidal force of the moon and the sun, which according to some scientists are not sufficient enough to drift the continents. The tidal force identified by Wegener to account for the supposed westerly drift of the continents would need to be several million times as powerful to produce the required movement. According to Woolridge and Morgan, 1959, the differential gravitational force and the force of buoyancy are not adequate to cause equator movement of the continents. Wegener's continental drift theory is criticized based on his idea related to the formation of the fold mountains along the western margins of North and South America, like Rocky Mountains and Andes Mountains. Critics considered that the idea of mountain formation on the western edge of the continents is unscientific. According to Wegener, the cealic masses, that is continents, are freely floating over SEMA without any friction offered by SEMA. In the latter part of his theory, while explaining the origin of the fold mountains, he has described the forceful resistance provided by SEMA in the free movement of cealic continents to explain the origin of the fold mountains along the frontal edges of the moving continents. Wegener's idea of mountain formation on the western edge of the continents is considered unscientific in nature. Besides, this theory could not provide explanation for the formation of all the young fold mountains of the world. Another criticism raised against the theory of continental drift is related to the direction of the movement of the continents in certain geological periods only. He did not explain why the splitting of the Pangaea occurred in a particular geological period only. Why did the process of continental drift not started before the Mesozoic era? What kept Pangaea together till the Mesozoic era? Wegener could not provide an explanation as to why the continents were in the unified form in the pre-Carboniferous period. He could not provide a cohesive picture of the geological history of the earth. The coastlines cannot be repeated since the coastlines are subjected to erosion and deposition over a long period of time. Despite all these criticisms, the theory of continental drift is nearly universally accepted now as a model of the way the continents are evolved. Continental drift theory explains about the present day arrangement and the distribution of the continents and oceans. The theory explains about the mountain building mechanism along the western margins of North and South America, that is the evolution of Rocky and Andes mountain. The theory contributes to the understanding of the origin of island arcs and festoons of Eastern Asia, West Indies, etc. The theory of plate tectonics is the advanced and the scientific version of the continental drift theory. The theory throws some light on the concept of paleomagnetism and polar wandering. The theory greatly contributes to the understanding of paleoclimates. The continental drift theory received scant attention from the scientific community. By 1926, the concept of the drifting of the continents were in full retreat. When Wegener died on the expedition across Greenland in 1930, his theory was already in eclipse. Though on some points Wegener's theory was rejected by the scientists, but the central theme of the horizontal displacement of the continents is considered and retained. In fact, the postulation of plate tectonics theory is the result of the continental drift theory. It is interesting to note that for continental drift, most of the evidences were collected from the continental areas. Information collected from the ocean floor and mapping provided new dimension in the understanding of this theory of continental drift. In 1935, Kiyo Wadati, a Japanese scientist, speculated that earthquakes and volcanoes near Japan might be associated with the continental drift. Deep focus earthquakes did not occur randomly over the Earth's surface, but were concentrated in the zones that extended in lines along the Earth crust. Benioff and Wadati and others wondered what could cause such pattern of deep earthquakes. A plot of various earthquakes and its pattern revealed as if the Earth's crust or the lithosphere is divided into parts. A number of discoveries in 1950s and 60s added new information to the geological literature, particularly the information collected from the ocean floor. Mapping provided new dimension for the study of the distribution of continents and ocean. The hypothesis of sea floor spreading is a new development which proves the theory of continental drift. The concept of sea floor spreading was put forward by Harry H. Hess and R. S. Dietz in 1960. Harry Hess in 1960s proposed that ocean floor was mobile and hot magma rises from the Earth's mantle by convection currents along the mid-oceanic ridges and moves on the either side, finally gets lost into the trenches situated along the continental coast. In spite of the fact that continents are old and permanent, they drift apart passively on the back of mantle generated convective currents. These facts prove that the continents and oceans are in constant motion. The concept of sea floor spreading is increasingly convincing evidence about the continental drift. The continental drift theory has gratified our curiosity related to the position of the continents and oceans in the past and how they changed and occupied their present location. He provided ample evidence from various disciplines to explain the drifting of the continents. Even though the scientists have not fully accepted the concept of the drifting of the continents initially, but post-continental drift theories, especially after 1950s and 60s like plate tectonics and sea floor spreading, not only provided recognition to the theory but validated the concept of drifting of the continents or the Earth's crust. The direct contribution of this theory is related to the formation of the continents and the ocean. Indirectly, its contribution to the most recent themes like paleoclimates, polar wandering and paleomagnetism is praiseworthy. Plate tectonics is the most advanced and scientific version of the plate tectonics.